While there is some resistance in the Python community to use design patterns, dependency injection in software development projects, these are general software development best practices which can help us and assist us in any programming language. Why does this resistance exist and where does it come from? I'm not sure. Maybe it's coming from the fact that Python is also heavily used in scripts. So in short scripts, you don't really want to over-complex the code. Maybe it's coming also from some past experience where all these made nonsense and made things more complicated. But I think when properly applied, then design patterns can assist us very much. So in this episode, we'll focus on the template method and the bridge design patterns. Two patterns which come together, and basically each of them can live by its own, but they are also used commonly together. So the template method, in a single sentence, I would tell you that it simply means that you have an abstract class and a base class, and then you have some subclasses, and the subclasses just override some method, and then we call it the template method. Okay, so it's an abstract class with abstract methods, and then we have subclasses, and the subclasses override some specific methods, and we call it the template method. Okay, simple enough. The bridge design patterns means that we have now a class hierarchy, as we said, because we said in the template method that we have an abstract class and subclasses, and they override the method, right? So if these abstract class and subclasses have too much logic and some logic that is not really related to this class, then in this case we can split it to two hierarchies, and one hierarchy, the abstract class, would receive the base class of the other hierarchy, basically some kind of a dependency injection. So the bridge just says that in your abstract class, in the constructor, it will have a parameter to the constructor that will receive the abstract class of the other type, and lo and behold, now we have a class that can use implementation from another hierarchy, and we have split the logic. Okay, so the bottom line is that design patterns are reusable solutions to common programming problems. They are proven techniques that help us to be more reliable, efficient, and scalable. And the template method and the bridge design patterns are two such design patterns that can be used to simplify the development. The template method design pattern is a behavioral design pattern that defines the skeleton of an algorithm in a base class, as we said, and allows the subclasses to implement specific steps, as we said, the specific functions that are inherited of the algorithm without changing the structure. The pattern is commonly used to implement algorithms that have multiple steps, such as checkout. Okay, in the checkout, I need to create the receipt, I need to process the payment, and checkout might differ from one person to another, or from one process to another. Sometimes it's grocery, sometimes I need to ship it, sometimes I don't need to ship it, so it's different. So we can have different subclasses. Each of them will implement the checkout method, and we'll have still the similar algorithms, but they would be different. In Python, specifically, we can implement the template method design pattern using inheritance. We can create a base class that contains the overall structure of the algorithm and a series of methods, calls, that are implemented by the subclasses. The subclass provides the implementation for each method that is called by the base class. So we can have the base algorithm on the base class, and then each concrete algorithm which would implement the specific methods or the specific steps would be each on its own concrete class that would inherit from the base class. The bridge pattern, the bridge design pattern, is a structural pattern that separates abstraction from its implementation so that they can be changed independently. In simple words, it just means we can pass the implementation of one class hierarchy into another by the constructor, something like dependency inversion of control, or usually used in dependency injection, where you are parsing objects inside the constructor of another one to be used, so you can change it. This pattern is commonly used when we want to decouple an abstraction from its implementation, making it easier to modify or replace either one without affecting the other. In Python, we can implement the bridge design pattern using composition. We can create an abstraction class that defines the interface for the client code and a series of implementation classes that provide the actual implementation of the class. So we have, again, an abstraction class, the operation of the abstraction class in methods, and in the init in Python, which is the constructor, we pass the implementation of the other class. And in this way, we can change the implementation from one class to another when they receive it. So in conclusion, both the template method and the bridge design patterns can be powerful tools to help us simplify the development of Python software systems. They separate the overall structure of the algorithm from the implementation. We can create more modular and flexible software systems that are easier to maintain and modify, and pass the implementation in the constructors and override methods. So this was the template method and the bridge design patterns, specifically in orientation of Python.